Well, welcome out to another hack a track for PyTrek. And in this mission, we had the opportunity to list blocks. And once again, noting that our high-level requirement doesn't have to match our flow. As a matter of fact, our show-kept names was simply a cognitive predefined procedure. In other words, we didn't have a other module that we had to call. We basically use that as an abstraction to say we know what we're doing. And more importantly, later on, it will be a predefined procedure we're going to call main loop that allow us to select many views, but we're getting ahead of ourselves. So let's go ahead and zoom over to our ready exploration to note that we didn't really have much of a change in our list structures, and we didn't have much of a change for our list files. And another thing we have to take away from this one is the idea of toggling our zero base. In this case, we're going to enumerate each one of our blocks as found in each one of our files, numbering our files for our file subscript, and then numbering our subscript in each one of our blocks, which has our gatekeepers. If we start off with 0, of course, we see that we get our zero-based enumeration. But of course, if we toggle our enumeration to 1, we will fix one problem, only to create another. So if we're going to fix one of our edge conditions, as we'll be demonstrating next, we're going to have to do something more than simply toggle our zero base. So let's take a look at what we had to do for list blocks 2. Using the same high-level design, of course, just like our list blocks 1, list blocks 2, we'll list the name of our file after separating it or splitting it up to the OS path name from the system argv0, or the first command line that is always the same on every platform. On Python, that's a problem under C++ and other programming environments where we get whatever the operating system wants to put there, whether it's the file name or not. In Python, we can rest assured that always argv0 will have our path, and we can split that path up and take the very last argument. Notice this is different than taking the next to last argument forward. This is simply going -1 on array or square brace subscript. Incredibly powerful to give us our ability to identify our file so that we can, for example, make sure that list blocks 2 we identified the same whether we do it in code or not. So because we didn't import the sys module, and we don't need it anywhere else, went ahead and put our importation underneath our main name. And some interesting things about this program is that we're using regular expressions, another import that I use to create a regular expression for me. So if you don't know much about regular expressions, I do indeed have a regular expression opportunity as well as other educational content. And assuming that you find these type of expressions just as difficult to understand as the rest of us do, by taking that educational opportunity, you'll be able to understand that we're simply going to be looking to substitute something between the first substitution brackets that has anything in addition to a range of these characters, very easy when you know how, to our clause that has a quite literal colon at the end of it. Whew, that's tough, and it took me a long time to master that. It'll probably take you just as long. But the good news is that using artificial intelligence these days, I was able to create both of these without having to write it all for myself. And more importantly, the difference between reading and writing regular expressions is about the same we see in learning any other foreign language. In other words, some people are good at listening comprehension, some people are good at writing, some people are good at speaking, but at a minimum, we should all know how to read what's going on. In this case, we have looking for a class. That's why we call it a pattern class when we compile it. Otherwise, we're looking for a pattern of both a class, and as you can imagine, that's pipe means an or a def. Once again, everything else being the same. So with the rise of AI, I wouldn't put so much emphasis on speaking regular expressions. And to tell you the truth, regular expression parsing can be a bit different between, for example, Perl, PHP, and Python, let alone Java and other languages. But what is really wonderful about this 80-20 rule here is that we're telling it to look for these things are gatekeepers across a multi-line parsing. In other words, you see there are no new lines here, and multi-line guarantees that we can span lines, and therefore our 80-20 rule has now been solved. So going through our enumerated list, we move the enumeration from our list files down here to our actual implementation. This is going to become a main block pretty soon. We'll simply go through each one of our file name sorted list for our file subscript. Once again, not much change on our block subscript. And we're going to keep things working at 0. So we can get rid of the 0, and that'll be our default. See how we're going to use our both patterns to find everything in our begulped data as read from our file handle. Simple. 3 or 4 lines to replace an entire block of code here so as to run our module, and you see exactly the same results. So let's take a look at fixing some of these edge conditions as well as cleaning up our code a little better. An important feature to be familiar with, if you don't already know it, forgive me if you do, is the quargs, or keyword arguments. And whenever we have a keyword, you can imagine we're going to have our arguments that have tag value pairs. Or what does that mean? In my mind, obviously, a dictionary. So once we have a dictionary, of course, what can we do? Well, we can check to see if the word class, for example, is in quargs. And if class is in quargs, we'll go ahead and compile for the class. Otherwise, by default, we're going to take both the class as well as a def. So class basically says, I only want to have the manifested listed for classes. Next, we're going to have for path, either the present working directory, but if path is in quargs, of course, we're going to get that path. The same thing for file type, default to Python. Otherwise, we're going to get the quargs for that key value of the file type. Everything else is pretty much the same. We're going to go ahead and list our file out of our sorted list of files. And to fix our previous class problem, in other words, that very last one, we had a annoying 0 to manifest, we're simply going to detect if we had a previous class. The default, of course, for each file is going to be false. So if we do find, simply by adding a class detector, like we had for our block detector with the def, we can simply say, hey, dude, we did indeed have a previous class. So now when we go through our block to detect our def, if we had a previous class, we're going to simply add 1 to whatever the subscript is, keeping our format at 0, 2. Then we're going to continue onward to our next block. Otherwise, we're going to simply not add 1 and see things naturally ordered if we had a previous class. Very easy to understand, very easy to work with. And of course, we decided to import sys up at the top here because now our main loop is moved out of our dunder name and become part of our main or main loop activity. So we can possibly realize and remember that main loop is simply what we're going to see as a convention that tells us there's something main going on, but we could just have easily have called this main loop reporting if we wanted to. Nothing magic about that name, but what is magic is the ability to have a key taking from the input section of our command line, which allows us to specify a literal string, which will be detected by the reporting loop and then assigned to our path to be used in our list files opportunity. Pretty slick, isn't it? Well, one of the things we're doing here, of course, is getting ready to weaponize this and put reporting as part of an ARGV or ARGC or a main loop interface to the command line interface, which is one of the reasons why we should know about. And in this lesson, let's go ahead and prove to ourselves that things run as we expected. And sure enough, here we have our 1, 2, 3, 4 and our 1, 2 whenever we don't have any classes. And interestingly, one thing to be sure of is when we have nothing in our glyphs, rather than having people freak out because these two are jammed up, one of the things we wanted to do was simply say there are no blocks. We had no blocks here. We have no blocks for dunder and it. We had no blocks for our test strings. That would be really interesting to have our AI detect if we all of a sudden had a block show up where there was no blocks previously. So we fixed several edge conditions as well as decided to get ready for reporting activity. And with this video, allow me to announce that we are putting together another open source project up on GitHub, where you can watch the future migration of this list blocks utility into a tool we're calling LISTO, L-I-S-T-O, which is Spanish for ready. So if we're going to be ready for world distribution, of course, we need to realize that we should start off in our edge detection mode simply by setting previous class to 1 rather than a Boolean. And if we have that condition, we're going to simply want to turn that previous class off. And turning that condition on or off will allow us to eliminate some code to simply have an offset, an integral offset, that we can use to once and for all bump our block count up by 1 to handle a not too distant edge condition of having, for example, several defs outside of a class, followed by a definite class definition, thereby requiring each and every block count to be updated by 1 for the entire count of block definitions we find in our file. So the conclusion here is that both list blocks and list blocks 2 have the exact same requirements, and although they have different implementations, the high-level requirements don't have to be changed, and the low-level flow of components could indeed change a good deal. So sometimes it makes more sense to have high-level documentation when it comes to acceptance rather than low-level documentation, because to tell you the truth, as we've just demonstrated, the structure of our code can change a lot. The next diagram I'd like to share with you, whether you have seen one or not, is a very high-level definition of a diagram that would allow us to understand the sequence of operations in our code. When we take a look at our predefined modules from list blocks, the segregation of our sequence of operations simply was forced to look like our previous diagram, where I had a predefined procedure for list blocks and a predefined procedure for showing our kept names. And this is definitely not part of the standard. Here again, demonstrating how I want to take license with best practices so as to make things more understandable for people, and more importantly, to show that very shortly we're going to have a show kept name number reporting capability, and it will be a predefined procedure, just like list blocks is the name of our file at the time of our understanding. So of course we know we're going to have a PWD, and that's going to be fed into list files. And to get ourselves used to what we can see, we're going to see that we're going to have the PWPy file set returned, and we're going to sort it locally rather than the list files, tasking our main list blocks routine to do that, followed by for each file the enumeration to get the keeper, and then all the keepers will come back and forth for each file, and then once we're done, we're going to return back to list blocks. Now this is not a perfect sequence diagram. That's a very high-level diagram, and we've already taken license with the standards by having our predefined procedures as well as other procedures, but it does indeed accurately reflect our understanding of our problem domain right now. And we need not get pedantic so as to confuse our team members anymore, because we're going to be talking about the sequence of operations using this exact same diagrammatic convention when we get to our network discussions later on.